Welcome to Sleepy Harbour. Settle in. Wherever you are right now, whatever the day left behind in you, let it start to loosen its grip. Because you do not need to carry any of it into the next couple of hours. There is nothing here that asks anything of you. No decision to make, no thread to hold on to, no place you need to be. Just this voice, and the slow tide of it, and the long, quiet stretch of night ahead of you, like calm water past the last of the harbour lights. Get comfortable. Let your shoulders come down from wherever they have been hiding all day, up somewhere near your ears. Let your jaw go soft. There is a particular way the body sits when it finally understands the day is over. And if you let it, it will find that way on its own, the same way a boat that has been fighting the current all afternoon finally turns and lets the tide carry it in. You do not have to steer anymore. You are moored. You are safe. And you can listen with your eyes closed, because none of what follows needs to be watched. It only needs to be heard, slowly, and then, when you are ready, let go of. So let me tell you a story to fall asleep inside of. It is a true one, which is the best kind for nights like this, and it begins with a man walking into a room built to hold no sound at all. It was 1951. The place was Harvard University, and the room was something called an anechoic chamber. That word looks strange written down, but it comes apart gently once you hold it. Anechoic, without echo. That is all it means. A room built, deliberately, painstakingly, to have no echo whatsoever. You know the way your voice bounces back to you a little in an empty kitchen, or the way a stairwell throws your footsteps back up at you, that faint doubling that tells your ears, without you ever thinking about it, how big the room is and how far away the walls are. An anechoic chamber is a room designed to take all of that away. The walls, the floor, the ceiling, every surface lined and shaped so that any sound you make goes out into it and simply never comes back. It is swallowed, the room drinks it and returns nothing. And so a person standing inside one is standing in something most of us will never experience in an entire lifetime. A space with no reflections in it at all. An acoustic dark as complete as a room with the lights off is to the eyes. The man who walked into that room was a composer named John Cage, and he went in expecting a very particular thing. He expected silence. He was a man who thought a great deal about sound and about the spaces between sounds, and he wanted, more than almost anything, to know what pure silence actually felt like. To stand inside nothing. To hear, for once, the true and total absence of sound, the way you might imagine it exists somewhere at the bottom of the deepest, stillest well. He wanted the nothing. He had come a long way in his thinking to find it. And here is the thing that happened, the thing that is going to sit at the very centre of everything I am going to tell you tonight. So let it settle in gently and stay. He did not find silence. He walked into the quietest room he had ever been in, a room built by careful people specifically to give him the closest thing to nothing that human engineering could produce. And instead of nothing, he heard two sounds. Two. One was high. A thin, bright, continuous whine, up at the top of what a person can hear, the sort of sound you might not even notice you were hearing until everything else fell away beneath it. And the other was low. A soft, dull, rolling rumble underneath everything, patient and steady, coming and going in a slow rhythm he could not turn off. Now Cage did what any of us would do. He was puzzled. He had been promised nothing, and he was standing inside two somethings, and he could not for the life of him work out where they were coming from. So he went and found an engineer, one of the people who had built and maintained the room, and he described the two sounds, the high whine and the low rumble, and he asked what they were. Where were they leaking in from? What had gone wrong with the perfect silent room? And the engineer told him something that Cage carried with him for the rest of his life. The high sound, the engineer said, was his nervous system. The bright, thin, continuous whine at the top of his hearing was the sound of his own nervous system operating, and the low sound, the slow rolling rumble underneath, was his blood moving through his body, in circulation, the great quiet ocean of it going around and around as it had done every second of his life, without him ever once hearing it. Sit with that for a moment. Softly, the way you would sit at the edge of the water and watch it without needing to do anything about it. A man went looking for the sound of nothing, and what he found instead was the sound of himself. The two sounds he could not escape were not coming into the room from the outside world. They were coming from inside him. They had been there his whole life. It was only in a room quiet enough to take everything else away that he could finally hear the machinery of his own living, the electric hum of his nerves and the tide of his blood. Sounds that had never once stopped, not for a single moment, from the day he was born. And Cage came out of that room a changed man, in a small and quiet way, because he understood something in there that he had not understood before he went in. He concluded that there is no such thing as true silence. Not for us. Not while we are alive to listen for it. As long as you have a nervous system humming and a heart pushing blood around your body, there will always be a sound, because you are the sound. The silence you imagine, the pure and perfect empty nothing, does not exist anywhere a living person can go, because the living person brings the noise with them. It changed his music too, the next year, in 1952. He wrote a piece called 4 minutes and 33 seconds, written the way you would write it on a page, 4'33 double apostrophe. And that piece is famous now, or infamous, depending on who you ask, because in it the performer sits at the instrument and does not play. For 4 minutes and 33 seconds, no notes are deliberately made, and the point, the whole gentle point of it, was the thing Cage had learned in that room at Harvard, that there is no silence to perform, that in the space where the music is supposed to be, the room fills up anyway, with the shifting of people in their seats, the small coughs, the hum of the building, the rain if there is rain, the sound of your own breathing, the sound, if it is quiet enough, of your own blood. He was not giving the audience nothing. He was giving them the chance to finally hear all the sound that was always already there, the sound underneath the sound, the noise that never stops. That is where we begin tonight, with a man who went looking for silence and found himself instead. And I am telling you this first, right at the start, because it opens a door onto the strangest and most comforting idea I know, and it is the idea we are going to walk through slowly together, one fact at a time, for the next couple of hours, until you have drifted off somewhere in the middle of it, which is exactly what I hope you do. Because here is what I am going to do for you tonight. 25 facts. 25 true things about silence, and about what silence actually does to the human brain, all of them laid out slowly and gently, one after another, like stones set down along a path, so that you never have to hurry and you never have to hold more than one of them in your mind at a time. Some of them will surprise you. A few of them are genuinely strange, stranger than the calm way I am going to tell them. and running underneath all 25 of them, like that low rumble of blood underneath everything Cage heard, there is going to be one single question, one quiet thread I want you to let me follow all the way to the end. You do not have to remember it. I will carry it for you, but I will tell you what it is now, so that even as you slide down toward sleep, some part of you knows where the tide is taking you. The question is this: if silence is not actually what the brain wants, then what is? Because we have all been sold silence. It comes to us as a product now, doesn't it? Quiet as a kind of luxury. Silence as the thing you are supposed to be chasing, the empty calm room, the pure and peaceful nothing, the promise that if you could just get away from all the noise, all of it, you would finally be at rest. Silence gets sold to us as wellness, as the answer, as the destination. And almost no one ever stops to explain what it actually is, or what it actually does to you, physically, inside your skull, when you get it. It is treated like a mood, like a vibe, a thing you should simply want more of. But counted out slowly, one careful fact at a time, the real science of silence tells a different story than the one on the label. A stranger one. A better one, I think, for a person lying in the dark who has always felt, quietly, that they cannot quite do the pure silence thing, and has wondered if that meant something was wrong with them. It does not. I promise you, it does not. And by the time we reach the end of this, you are going to understand exactly why the thing you do to fall asleep, the voice or the sound you keep on, the reason you are here right now, instead of lying in a perfectly quiet room, is not a weakness at all. It is the correct answer. Your brain has been solving this problem correctly all along. But we will get there slowly. There is no rush tonight. There is never any rush here. Before we go on, let me ask you something, and you do not have to move to answer it. You can just let the answer form somewhere behind your closed eyes and leave it in the comments in the morning if you feel like it, whenever you happen to wake. I would genuinely like to know where in the world you are listening from tonight. What harbour, what city, what quiet, dark room, what time it is where you are. There is something I find steadying about the thought of all of us, scattered across the whole turning world, in our separate beds, following the same slow story down into the same sleep. If you tell me where you are, I read them. I do. And if you are new here, if you have only just drifted into Sleepy Harbour for the first time tonight, you can subscribe, and then there will always be another one of these waiting for you. Another long, slow story for the next night you cannot quite find your way down on your own. That is all. That is the only thing I will ask of you the whole way through. Now let it go, and let us get back to the water. So, silence is sold to us as calm, as the good thing. And the very first place that story starts to come apart is in a laboratory, in a study published in the year 2006. In a medical journal called simply Heart the Study, was led by a researcher named Luciano Bernardi, and it has one of the loveliest titles a scientific paper has ever had. It was called The Importance of Silence. Now stay with me, because this one is quietly astonishing, and I want to lay it out for you slowly enough that even half asleep you can feel the shape of it. Bernardi and his team were interested in what different kinds of music do to the body. Not to the mood, not to how people said they felt, but to the actual body, the measurable machinery of it. Your heart rate, how fast the heart is beating, your blood pressure, the force of the blood pushing against the walls of your vessels, your breathing rate, how fast the air is going in and out, the real, physical, ticking over numbers of a living person. And so they had their subjects lie there and listen to different styles of music, one after another, all sorts of it. Some fast and driving, some slow and soothing, the kind of gentle track you would put on precisely because someone told you it was relaxing. And they watched the numbers change. When the music was fast, when the tempo picked up and drove along, the body responded the way you might expect. Breathing sped up, blood pressure rose, the system leaned forward, roused, a little more awake, a little more on. And when the music slowed down, when the tempo eased off and the track went gentle, the numbers came back down. Breathing slowed. Blood pressure eased. The body settled. So far, nothing shocking. Fast music winds you up a little. Slow music calms you down a little. We more or less knew that. But here is the part that makes this study one of the small, quiet landmarks in everything we understand about silence. Between the tracks, at random, the researchers inserted pauses, little gaps of silence, 2 minutes of nothing, dropped in here and there between the pieces of music. And they were not really the point of the experiment, at first. They were more like the spaces between the stones, the rests between the notes, the ordinary blank moments you would not think to measure. Except they measured them anyway. And when they looked at what the body did during those 2-minute silences, they found the thing nobody was expecting. The silence relaxed people more than the relaxing music did. I want you to hear that slowly, because it is easy to let it slide past. They had chosen music specifically designed and known to be soothing, the calm and gentle stuff, and they had measured a real physical relaxation from it, the heart slowing, the pressure easing. And then the silence came, the empty 2-minute gap, with no music in it at all, and the body relaxed harder. The heart rate dropped further, the blood pressure fell more. The breathing slowed more deeply in the silence than it had in the soothing music that surrounded it. The single most relaxing thing they measured in the entire study was not any track they had chosen. It was the nothing they had left in between. The relaxation, it turned out, came in the gaps, not in the tracks, in the spaces between the tracks. And if that were the whole finding, it would already be a beautiful one to fall asleep to, the idea that the calm you are chasing is not in the soothing thing itself, but in the quiet on the far side of it. But Bernardi's study found something even finer than that. One more turn of the screw. And this is the detail that I want to leave you with tonight, as the tide starts to take you, because it is going to matter for everything that comes after. The silence was most powerful when it arrived after the arousing music. Think of that. The 2-minute pauses did not all do the same thing. A pause that came after a slow, gentle track was pleasant enough. But a pause that came right after a fast, driving, exciting piece of music, that was where the body relaxed the hardest of all. The deepest calm, the biggest drop in heart rate and pressure and breath came in the silence that followed the stimulation. As if the body needed the contrast. As if the quiet only became truly powerful when there was something loud right behind it for the quiet to be an escape from. The brain relaxed most, not in flat, unbroken stillness, but in the sudden drop, the coming down, the exhale after the effort. The relaxation was in coming down from the sound, not simply in the sound being gone, in the falling away of it, in the contrast between the noise a moment ago and the quiet now. And I want you to notice, without straining, how strange that already is compared to the story we get sold. The story we get sold says silence is a pure and constant good, a flat calm you should soak in like a warm bath. More of it always better than less. But the very first serious look at what silence does to the body says something more delicate and more interesting than that. It says the power of the quiet is not in the quiet alone. It is in the relationship between the quiet and what came before it. It is in the release. The silence that follows the storm is worth more to your heart and your lungs and your blood pressure than silence that has been there forever with nothing to compare it to. Which brings us, gently, right back to the question I promised I would carry for you. Because if the calm is really in the coming down, in the contrast, in the release from sound, rather than in the absence of sound itself, then what does that tell us about pure, total, endless silence? The kind John Cage went looking for in that room at Harvard. What happens when you take away not just the loud sound, but all of it, every last reflection, until you are left in a quiet so deep you can hear your own blood? Does the brain finally rest the way the wellness label promises? Does it sink into the pure calm nothing it has supposedly been craving all along? Or does something else happen? Something stranger? Something that most of the marketing about silence would really rather you did not know? Hold that. Do not answer it. Let it float there in the dark, unanswered, the way the low rumble floated underneath everything Cage heard. Because that is exactly the water we are going to sail into next, slowly, in no hurry at all, and it starts in the quietest rooms that human beings have ever managed to build, rooms so silent that scientists have had to measure them in numbers below zero. Rooms where the first thing a visitor hears when the door seals shut behind them is not peace and is not calm, but the sound of their own heart. For now, just breathe. Let the numbers in your own body do what Bernardi watched them do. Let the day be the fast, loud music, and let this, right here, be the silence that comes after it, the gap, the pause, the coming down. You have been driving along at speed for hours and hours. This is the part where the tempo drops. This is the exhale. Feel how the shoulders keep sinking, a little more with each slow breath. Feel how the jaw keeps softening, how the weight of you settles a little deeper into the bed, into the pillow, into the safe dark of the room. There is nowhere to be. There is nothing to answer. There is only the next slow fact, and then the next, laid down one gentle stone at a time along the path that leads you down and out into sleep. We have only just left the dock. There are so many quiet, strange, comforting things still ahead of us tonight, and you do not have to stay awake for any of them. If you drift off in the next few minutes, you will have gone exactly where I hope to take you. And if you are still here, still following the low sound of this voice down through the dark, then come with me a little further out onto the calm water. Because I want to take you now into the quietest place that has ever been measured on the surface of the earth, and I want to tell you what it does to the people who step inside it, and why almost none of them can bear to stay. But that is the next part of the story. For now, the harbour is still, the water barely moves, and the only sound, if you listen for it the way Cage listened, is the one that has been with you your whole life, going quietly around and around, keeping you, holding you, carrying you gently on toward morning. There is a building in Redmond, Washington, inside the campus of a technology company that most people walk past every day without knowing what is inside it. It looks, from the outside, like almost any other low, functional structure in that part of the Pacific Northwest, the kind of building you might assume contains servers or storage or rows of desks under fluorescent light. Building 87, it is called. And the room inside it, the room that sits at the center of that building, the way a stone sits at the center of a sealed box, is the quietest place that has ever been measured on the surface of the earth. The number is 20.35 decibels. That figure was confirmed by Guinness World Records in 2015, and I want to stay with it for a moment, because it is the kind of number that resists the imagination the first time you hear it, and then, if you let it settle, becomes something close to vertiginous. The 0 point on the decibel scale, the true zero, is not silence. It is the very faintest sound that a healthy young human ear can detect under ideal conditions, a sound so small it is essentially nothing. The auditory equivalent of the faintest possible feather laid against the eardrum. That is the baseline. That is the floor that most of us carry around in our heads as the definition of nothing. And the room in Building 87 measures 20.35 decibels below that floor, below the threshold of human perception, below the point at which a healthy ear can find any purchase on what is happening in the air around it. To achieve this, the room was not merely soundproofed. It was architecturally isolated from the world in a way that sounds, when you describe it slowly, almost excessive, almost comic, until you understand what they were trying to eliminate. The walls, the floor, the ceiling, all of it rides on a system of springs and isolation mounts designed to decouple the room from the building. The way a boat hull is decoupled from the water by its own buoyancy, so that no vibration from the structure around it, not from an vac system, not from a footstep in the corridor, not from the hum of the city itself, can find its way through to the interior. It is a room designed to be mechanically alone. A room that does not touch the world. The walls are lined with acoustic wedges, long triangular forms that absorb sound rather than bouncing it back, so that what enters the room from the inside does not return. Most rooms you have ever been in, every room you are thinking of right now, the room where you are lying in the dark tonight, all of them are full of reflections. Sound leaves one surface and strikes another and then another, and your brain, without your awareness or consent, uses those reflections the way a bat uses its own calls, to read the size and shape of the space, to locate you within it, to tell you where the walls are and how far away the ceiling sits above you. You live inside a constant, silent conversation between sound and space. And you have never once had to pay attention to it, because it is simply always there, running in the background, part of the texture of being in a room. In Building 87, all of that is removed, the reflections are gone. And in their place is something that takes a few seconds to register as different, and then a few more to register as wrong, and then, after a little while longer, as something stranger than wrong. Before Building 87, the record belonged to a different room, in a different city, a room that still exists and still quietly holds its second place the way a retired champion holds a photograph of the belt. Orfield Laboratories in Minneapolis, Minnesota, founded by Stephen Orfield, a researcher who has spent decades studying how environments affect human experience, how the acoustics of a space change the people inside it, how silence in a hospital room is different from silence in a concert hall, how the sound of a place shapes the body that occupies it in ways that most designers have never thought to consider. His chamber was measured at 9.4 decibels. Not as deep as Redmond, but still below the floor of human hearing, still into that territory most of us have no word for. His room, too, is lined with fiberglass acoustic wedges. The effect is the same. Approximately 99.99% of all sound that enters the room is absorbed. The word anechoic, which is the technical name for this kind of chamber, an anechoic chamber, comes from the Greek and the Latin, meaning in the most direct translation, without echo, without the return. A room in which sound goes in and does not come back. And here is the thing. Here is the thing that most accounts of these rooms note but then move quickly past. Because what comes next is stranger and more interesting. The technical description of an anechoic chamber, the springs, the wedges, the negative decibels, the absorbed reflections, is the engineering. The engineering is not the story. The story is what happens to the person standing inside one. Because you would assume, perhaps, that walking into the quietest room ever built would feel like relief. Like the relief of closing a door against a storm, the relief of removing headphones after hours of wearing them, the relief of lying down in a dark room after a day that was simply too loud. You would assume it would feel like rest. Like arrival, like the thing you have been looking for. It does not feel like that. The first thing most people notice is not what has been removed. It is what remains. Or rather, it is what has always been there, running beneath the surface of every moment of your life, under every conversation and every piece of music and every ambient wash of city sound, present for every second of your existence, and never, until this moment, audible. Your own body, the sounds your body makes, simply by being a body, simply by being alive. Your heart. Not as a metaphor, not as a figure of speech, but as an actual audible event, the low rhythmic percussion of your own cardiac muscle doing its work, the one it has been doing every moment since before you were born, that you have never once had to listen to because there was always something louder. In an anechoic chamber, in the deepest quiet available on the surface of this planet, the heart becomes audible, the blood becomes audible, a low rushing sound, a soft and biological tide moving through the vessels of your own body, in and back, the quiet industry of your own circulation suddenly no longer masked by the world. And then the breath, the faint papery sound of air moving through the passages of your nose and throat and lungs, the sound of your own swallowing, the microscopic creak of your joints when you shift your weight, the faint stretch and settle of your own skin, all of it present, all of it always there, all of it newly, startlingly, undeniably audible the moment the world stops covering it. Visitors to anechoic chambers report this consistently and have reported it for as long as the rooms have existed. The experience is not of entering emptiness, it is of entering a strange intimacy with your own body. A room that was supposed to contain nothing turns out to contain you, more completely and more specifically than any other room you have ever been in. This was, in a sense, precisely what John Cage discovered in 1951 when he walked into the anechoic chamber at Harvard University expecting to find silence, and found instead those two sounds, the high, continuous whine that an engineer told him was his nervous system, and the low, persistent rumble that the engineer identified as his blood in circulation. Whether the engineer's precise physiological attribution was accurate in every detail is a question that has been gently debated in the decades since. What is not in question is what Cage heard. What is not in question is what the experience did to him. He left that room convinced of something he had not believed when he entered it. He left convinced that silence does not exist. Not because there is always noise from the outside world, not because cities and wind and animals are always generating sound, but because as long as there is a living body in a room, that body is generating sound, and that sound will find its way to the surface the moment everything else steps back. 2 years later, in 1952, he completed the piece that the Harvard Chamber had made inevitable. 4:33. 4 minutes and 33 seconds of a performer sitting at a piano or any instrument and playing nothing, not pausing before the music, not resting between movements, playing nothing deliberately for the entire duration so that the audience, waiting for the music to start, would gradually become aware of what was actually in the room. The rustling of coats, the sound of rain on the roof, the slow ambient exhalation of a crowd of people breathing together. The music Cage had found in the chamber, the music of what is present when nothing is added. Now let us return, carefully and slowly, to those negative decibels, to the 20.35 of Redmond and the 9.4 of Minneapolis, because there is a question embedded in those numbers that most reporting on these rooms never quite gets around to asking. What is the theoretical flaw? How quiet can a room ever be? Is there a limit? And if there is a limit, where does it come from? There is a limit, and it comes from the air itself. The air in any room, at any normal temperature, is not still. It cannot be still in the strict physical sense, because the molecules that make up the air are in constant, ceaseless, random motion. Billions upon billions of molecules, each of them drifting and bouncing and colliding with the molecules around them in a motion that has no pattern, no direction, no purpose. That is simply what molecules of gas do when they are at a temperature above absolute zero. This random thermal motion has a name, Brownian motion, named for the botanist Robert Brown, who observed it in 1827 in pollen grains suspended in water, who noticed that they never quite held still, that they moved in tiny, perpetual, apparently purposeless ways, and who understood that something unseen was pushing them. At room temperature, the random thermal motion of air molecules generates a faint acoustic hiss, a sound produced by no living thing, no machine, no source outside the air itself. Simply the sound of air being air, of matter being matter, of warmth persisting at ordinary temperatures. That sound has been measured at roughly 23 to 24 decibels, and that is the flaw. The physical basement. You cannot make a room quieter than the air that fills it, because the air itself is not quiet, and nothing you can do with fiberglass wedges or vibration damping springs will touch the Brownian motion of the gas molecules moving in the space. Silence, as a measurable quantity, as a thing you can put a number next to, has a hard bottom set by physics. And that bottom is not zero. It is not nothing. It is the sound of the air being air. It is the sound of ordinary matter at ordinary temperature doing what ordinary matter cannot stop doing. There is something oddly comforting in that, if you let yourself sit with it. The universe does not produce silence, not even in the most perfectly engineered room ever built, not even at the furthest frontier of human acoustical achievement. There is always something left, always some faint, ambient, sourceless hiss, always the thermal shuffling of matter, keeping its own quiet and ceaseless company. So when we talk about these rooms, about what it feels like to stand inside them, we are not talking about nothing. We are talking about the residue, the irreducible minimum, the hiss of the air itself, plus the sounds of your own body, brought to the surface by the removal of everything that normally covers them. And the question of what that experience does to a person, which is a question the engineering cannot answer by itself, is a question that runs considerably deeper than the decibel count. Here is a study. A small, careful study conducted in 1953, more than 70 years ago now, by two researchers named Heller and Bergman. What they did was simple. They recruited a group of subjects, all of them with normal, healthy hearing, no tinnitus, no known auditory condition. And they placed each subject, one at a time, inside a very quiet, soundproofed room. Not an anechoic chamber, not a room with negative decibels, but a room quiet enough that the ambient noise was well below the threshold of normal hearing. And they asked each subject to sit inside the room and report any sounds they heard. What they found was this: 94% of the subjects, almost everyone, reported hearing sounds. Ringing, buzzing, hissing, a faint, high, persistent tone, or a low one, or a shimmer, or a whistle, or a rushing sound, or some combination of these. Sounds that were not there, that had no physical source in the room, that came from nowhere outside the subject's own skull. 94%. Within approximately 5 minutes of being placed in genuine quiet. This is not a disorder. This is not a malfunction. This is not a symptom of anything wrong with the people who reported it. This is, as best current understanding can explain it, a feature of the way the auditory system is designed. Because the auditory system does not simply sit passively and wait for signals to arrive. It is not a microphone. It is an active, dynamic system, constantly adjusting its own sensitivity to match the conditions it finds itself in, constantly tuning and retuning in response to the environment around it. Think of it this way. Imagine turning up the volume on an amplifier in a quiet room. The room is not silent. There is still a faint hiss, a low ambient texture, but as you turn the gain up, that hiss gets louder. The system, trying to find a signal, begins to amplify not just the signal, but the floor beneath it, the baseline noise that was always present, but previously too faint to matter. The system cannot distinguish between a signal that is genuinely quiet and a floor that has been amplified. It simply responds to what it detects, turns up the gain until something comes through. The auditory brain does something analogous. In the absence of incoming sound, in the absence of the constant, varied, information-bearing signals that it normally processes from the outside world, it does not simply go quiet and wait. It turns up its own sensitivity. It amplifies its own internal hiss, the background noise generated by the nervous system itself. The spontaneous electrical activity of the auditory neurons, the low-level firing that is always present in any living neural system, always running in the background, always there. And when that internal hiss is amplified enough, when the gain is turned up high enough, it begins to sound like something. Not a signal from the outside world, not a real sound in the ordinary sense, but an experience of sound, a genuine perception, a ringing or a buzzing or a hissing that feels, from the inside, exactly as real as any other sound you have ever heard. Because from the inside, it is real. The brain has no way to flag it as internally generated. The brain receives the signal and does with it what it does with all signals. It hears it. 94% of normal hearing people within 5 minutes of genuine quiet. If you have ever sat in a very quiet room at night, the kind of quiet that only comes when the city has gone down to its lowest murmur and the building has stopped its creaking and the wind has dropped, and noticed, beneath it all, a faint ringing. A faint high tone that seems to be coming from somewhere and everywhere and nowhere. You have not found something wrong with yourself. You have found the flaw of your own auditory system. The sound your brain makes when it is listening hard and finding nothing to report. That sound, that quiet ringing, is one of the most universal of all human perceptual experiences. Most people never mention it because most people, most of the time, are surrounded by enough sound that it never surfaces. But it is there. 94% probability that it is there, waiting, every quiet night you have ever spent. There is one more thing that happens to people in the deepest quiet rooms, and it is the thing that surprises them most. The thing that nobody quite expects when they step through the door of an anechoic chamber expecting a meditation room and find instead something that their body does not know quite what to do with. The thing that makes the laboratories recommend, as a practical matter, that visitors sit down before they spend too long inside. In a normal room, at any moment of the day or night, you are receiving a constant, faint, mostly unnoticed acoustic map of the space around you. Every sound that leaves your body, the soft sound of your own movement, the displacement of air as you shift your weight, even the biological sounds of your own breathing, reaches the walls and the floor and the ceiling and returns to you, just barely, at a delay so small you cannot consciously detect it, but large enough that your brain can use it. Those reflections tell you, in a language that never reaches consciousness, but that the brain reads fluently, how far away the walls are, how large the room is, where you are inside it. They give you a kind of ongoing acoustic ballast, a constant low-level sense of where your body stands in relation to the space that surrounds it. In an anechoic chamber, the reflections are gone. The acoustic wedges absorb them. And what happens then is something that the body, which has spent an entire life expecting those reflections to be present, does not handle gracefully. People report disorientation, a subtle, groundless feeling, as though the room has removed one of the reference points the body uses to know where it is. A dizziness that is not quite the dizziness of spinning, not quite the dizziness of vertigo, but something harder to name, the mild, unnerving feeling of having lost a sense you did not know you were using. Your sense of space, your sense of where you are within a room, is not only a visual sense, it is not only the sense of the floor under your feet and the walls you can see. It is also an acoustic sense, built from the ongoing, unconscious processing of the room's reflections, the room's acoustic signature, the way sound bounces back to you from the surfaces around you. And when that acoustic signature is removed, when the room absorbs every reflection and sends nothing back, the body begins to feel, in a very quiet and unlocalized way, that the ground has become uncertain. Some people manage it easily, others find it unsettling more quickly than they expected. Stephen Orfield, whose laboratory in Minneapolis has brought many hundreds of visitors through that 9.4 decibel room over the years, has said in various accounts that the popular press reports about how long people can endure the chamber, figures of 45 minutes, are sometimes cited, framed with theatrical flair as the maximum any person has survived inside, are considerably overstated. Considerably more dramatic than what the actual experience delivers to most visitors. What is true, what is supported by what people actually report, is milder and in some ways stranger than the dramatic version. Most people find that prolonged total silence does not feel like peace, it feels like something to monitor. The quiet becomes an object of attention rather than a condition that enables rest. The room, which was supposed to contain nothing, turns out to be full of your own body, full of your own internal sounds, full of a faint ringing that is nobody's fault, full of a subtle groundlessness that the ears keep trying and failing to resolve. This is not, to be clear, a pathological response. It is not a sign of fragility or disorder. It is, in a meaningful sense, exactly the correct response to a genuinely unusual environment. The body is doing what the body is supposed to do. It is noticing that something has changed, something that was always present and is now absent, and it is adjusting, and the adjustment takes a little work, and the work is perceptible as something between unease and fascination. But it is not peace. Not in the way the word is usually meant. And this is the door that opens onto the deeper question, the one that has been waiting patiently at the back of all of this. What does it actually mean to say that silence is good for you? What does the research mean, the study in the journal Heart that found silence out relaxing music, the evidence for reduced heart rate and lower blood pressure and slower breathing in genuine quiet? What does it mean, given that the deepest quiet available, the most complete silence that has ever been engineered, sends most people looking for a chair and watching the door? The answer begins to take shape when you hold the two things together. When you hold the Bernardi finding that 2 minutes of silence produced a greater cardiovascular relaxation than the relaxing music that surrounded it, alongside the anechoic chamber finding that deep, prolonged, total silence is experienced not as rest but as vigilance. When you put those two things next to each other, a shape begins to emerge. And the shape is this. The benefit that the research found was not the absence of sound. It was the absence of sound that demanded interpretation. The silence in the Bernardi study came inside a musical context, inside a listening session, inside an environment where the silence was expected, where the brain knew it was a pause and not a change in the state of the world. It was a contextual silence, a meaningful gap, a rest within a phrase, and the brain treated it as such and released. The anechoic chamber offers something categorically different, not a pause within a context, but the removal of context itself. The removal of the acoustic world the brain uses to locate itself in space, to monitor for change, to understand what is happening around the body. And the brain, well trained by millions of years of living in a world that was never truly silent, treats that removal not as a rest, but as information. Something has changed. The world has gone quiet. And the world going quiet is, in the deep evolutionary language the body speaks beneath all language, a signal worth attending to. We will come to that evolutionary question more carefully a little later. For now, let it sit alongside everything else, the hiss of the air molecules moving, the sound of your own blood, the ringing in 94 out of every 100 ears, the gentle groundlessness of a room that sends nothing back. All of these are not problems with the rooms or with the people inside them. They are answers to a question that the rooms, by being so extreme, so complete, make possible to ask. What does the world actually sound like when everything that was added to it is taken away? And the answer, which is stranger than most people expect, is you. You are there. Your blood is there. Your breathing is there. The sound your nervous system makes in the dark, running its quiet, necessary rounds, is there. The faint ringing your brain generates when it turns its own gain up looking for a signal is there. The room was supposed to be empty, and it contains you entirely, more completely than any room that has ever had you in it. Settle that thought. Let it rest beside you in the dark. You are not surrounded by silence tonight, not in any way that the word means in its most extreme and technical sense. You are surrounded by the ordinary sounds of an ordinary night, the background fabric of a world that has never, in all the history of this planet, been actually silent, not while something was living in it, not while there was air above the ground, not while the molecules kept their endless warm Brownian wandering through the space. And your body, your auditory system, the thalamus and the cortex, and all the relay stations between them that are still running tonight, even now, even as you drift, even as the weight of the day loosens its grip on your muscles one by one, and the breath slows, and the thoughts begin to dissolve at their edges. Your body is not sitting in an anechoic chamber. It is not trying to locate itself in a room that sends nothing back. It is here, in this ordinary darkness, surrounded by the low and ordinary sounds of wherever you are, the sounds that carry nothing threatening, nothing interpretable, nothing that requires a response. The question, the real question that all of this has been pointing toward since we left the dock, is not whether silence is good for you. It is what kind of quiet the body actually recognizes as safe. And the anechoic chamber, for all its engineering achievement, for all its negative decibels and its 99% absorption, gives us the clearest possible answer to that question by showing us what happens when you push the experiment to its absolute limit. Silence, in its most complete and literal form, is not what the body reaches toward. It is something the body finds unusual enough to monitor. It is something the body treats as information. And what the body actually reaches toward, what the body actually relaxes into, is something more nuanced than absence, something more specific than nothing. It is the particular quality of sound that carries no demand, sound that is present but interpretively empty, sound that fills the acoustic space so the brain does not have to go looking for something in the gaps, but that carries no message, raises no question, names no threat, requires no answer. This is not a new idea in the sense that it is recent or surprising to researchers who work in this area. It is a new idea in the sense that it is almost never stated plainly. The conversation about silence and sleep and rest tends to get sorted into two camps. The silence is better camp, and the noise is better camp. And both camps tend to talk past each other because they are not actually talking about the same thing. Silence is better people are thinking about the removal of intrusive, unwanted, attention-demanding sound. Noise is better people are thinking about the anxiety of true quiet, the ringing in the ears, the groundlessness, the monitoring. Both of them are right about something real. Neither of them is talking about what the body actually needs, which is not silence and not noise, but a specific kind of presence, something there in the acoustic space that asks nothing. And all of that strange and particular and carefully verified finding is going to take us somewhere specific in the next part of this journey. Somewhere that concerns your own body specifically, your own ears specifically, what they are doing right now as you lie in the dark, what they were doing when you fell asleep last night, what they will do in the small hours of the night when the city drops to its lowest murmur and the building quiets around you and you are, for a moment, as close to silence as an ordinary life in an ordinary room will ever take you. Because your ears, unlike your eyes, do not close. They have never had a lid. And the part of the brain that manages what your ears report, that decides what to do with the incoming signal during the hours you spend unconscious, is not resting. Not in any simple sense. It is still at work, still screening, still sorting, still holding the night in its careful attention, looking for the one specific kind of sound that would justify pulling you back from wherever sleep has taken you. That is what is ahead of us, and we are moving toward it slowly, the way you move through water when the water is warm and the dark is comfortable and there is nowhere to be before morning. Think about what that means for a moment. Not abstractly. Concretely, in the terms of your own body, your own skull, your own night. Your eyes are closed right now, or nearly. The lids came down, the way they always do, softly and without drama, and behind them the visual cortex began its long retreat from the world of shapes and light. Vision for you is off, or near enough to off that the difference is small. There is a biological switch for that. There is a mechanism the body has evolved, refined and protected across millions of years, specifically so that the sense that costs the most energy, the one that draws the most signal and demands the most interpretation, could be powered down during the hours of darkness, leaving the brain free to do other things, leaving the muscles free to rest, leaving the system free to run its long overnight maintenance without the constant noise of everything you are looking at demanding to be processed and understood and responded to. Your eyes have a lid. That is not a trivial fact. It is a whole chapter in evolutionary biology, and it ends the same way every night, with darkness and with rest. Your ears do not. There is no lid for the ear. There has never been one. In the entire history of the body, through all the pressures and selections and the long, slow grinding work of adaptation, nothing ever arrived that could close the ear the way the eye is closed, and the reason, when you think about it, is plain and a little unsettling, and also in a strange way clarifying. The eye was safe to close because the ear would remain. Because one sense had to stay on. Because the world does not stop happening while you sleep, and the possibility of something arriving from the world, something loud, something sudden, something that meant danger, something that meant fire or flood or a predator at the edge of the camp, could not be dismissed simply because you had decided it was time to rest. Something had to keep watch. The body elected the ear. The ear has been keeping watch ever since. 13. Your hearing does not sleep. Not in any meaningful sense of that word. While you are unconscious, while the rest of you is as far from waking life as you will travel without dying, the thalamus and the auditory cortex, two structures deep inside the brain, one of them essentially a relay station sitting near the center of your head and routing incoming sensory signals to the places they need to go. The other a sheet of specialized tissue on the surface of each temporal lobe, the part of the brain closest to each ear, are still at work. They are still receiving. They are still sorting. The auditory cortex, which in waking life you might think of as the part of the brain that hears, is still accepting the signal from the ear, still processing what the ear reports, still doing something with the information that the night around you is generating every moment. It does not hear the way you hear when you are awake. That is important. It is not that the brain is sitting in there listening, in the way you listen when someone is talking to you, and you are following along, building meaning, forming responses. That kind of active, directed, engaged listening, the kind that costs attention and produces comprehension, mostly stops with consciousness. But a different kind of listening continues. A monitoring. A watchfulness that runs below the threshold of experience, below the level where you would ever know it was happening. processing the acoustic texture of the night and comparing it continuously against a template of what the night is supposed to sound like, looking for deviation, looking for the specific signal that would justify the cost of bringing you back. The brain, even asleep, knows the difference between sound that is background and sound that matters. It knows this the way a city dispatcher knows the difference between routine traffic on the radio and a code that means something has gone wrong. Most of what arrives at the ear in the night, the hum of the refrigerator, the distant sound of a car, the building settling in the cold, is filed as background. It arrives, it is processed, it is dismissed, and you never know any of it happened. But your own name, spoken quietly in a dark room, will pull most sleeping people partially or fully awake, even when sounds of comparable or greater volume do not. A mother will wake to the specific cry of her own infant and sleep through a neighbor's television at the same decibel level. This is not random, it is not sensitivity or hypochondria or light sleeping, it is the system working. It is the auditory cortex, in collaboration with other regions, running its screening protocol and recognizing a pattern it was told, by evolution and by experience, to treat as significant. The ear is always on. That is the baseline from which everything else about sound and sleep has to be understood. 14. But if the ear is always on, how does anyone sleep through anything? How do people in cities sleep through traffic? How do the people who grew up near a railway line stop noticing the trains? The answer is not that they stop hearing the trains, it is that the brain develops a mechanism for protecting sleep from the constant incoming signal. A mechanism for saying, I have heard this, I have evaluated it. It does not require action, and I am not going to pay the cost of waking in order to do nothing. That mechanism has a name, and it has a shape that can be seen on an electroencephalogram, which is the recording of electrical activity in the brain. The shape is called a sleep spindle. A sleep spindle is a brief burst of oscillating activity generated by the thalamus, the relay station. It lasts roughly half a second to 2 seconds, and on the recording it looks like a sudden, dense cluster of waves, a spindle shape that appears and then subsides. It arrives during the stage of sleep called stage 2, non-REM sleep, which is the stage most people spend most of their sleeping hours inside, and its function, among other things, is to gate, to block, to prevent the incoming sensory signal from making it all the way through the system and into consciousness. The sleep spindle, when it fires, is essentially the thalamus pulling a lever that says, "Not now. I have this. You do not need to wake for this." In 2010, a team of researchers published a paper in the journal Current Biology examining the relationship between sleep spindles and the ability to sleep through noise. The lead author was Tien Than Dang Vu, and what the study found was a relationship that was, when you sit with it, at once completely intuitive and genuinely surprising. People whose brains produced more sleep spindles during the night were better able to sleep through noise. Not just more tolerant of noise in a subjective reported sense, but measurably more continuous in their sleep when sound was present. The spindle was the gate, and people whose gates fired more reliably had demonstrably better protection. What that means, when you follow it to its conclusion, is that your ability to sleep through noise is not simply a matter of willpower or habit or character. It is, at least in part, a matter of hardware. The rate at which your thalamus generates sleep spindles is something that varies between individuals, and that variation has real consequences for how the acoustic environment of the night affects you. Some people are built with stronger gates, some people are built with weaker ones. and neither of those people has chosen their configuration in any straightforward sense. It is closer to the way some people are built with faster reflexes, or with a more sensitive sense of smell, or with a particular predisposition in the architecture of their inner workings that they did not select and cannot. Simply by deciding to change, this is worth saying slowly and worth letting settle. If you are someone for whom night noises feel more intrusive, for whom the traffic or the neighbour or the sound of the building at 3 a.m. is harder to sleep through than it seems to be for others, that is not a personal failing. It may simply mean that your thalamus is a lighter gatekeeper. It may mean that the mechanism that is supposed to hold the door closed against the incoming signal is doing so with less pressure than someone else's, and that the sounds of the night are finding their way further through the system before being classified and dismissed. The gate matters, and the gate is not the same for everyone. 15. But here is the part that catches most people off guard, the part that does not match the way we tend to think about sleep and sound, the part that rearranges the picture in a way that is hard to see once you have seen it. Even when you sleep through a sound, even when the noise arrives and the thalamus evaluates it, and the sleep spindle fires, and you do not wake up, even when by every conscious measure you are still asleep and unaware, and somewhere far from the surface of your own experience, the sound has not necessarily left the body without a trace. Nighttime sound causes what researchers call micro-arousals. The word arousal here does not mean waking, it does not mean becoming conscious. It means something narrower and more physiological, a brief shift in the state of the system. A flicker, a momentary change that registers in the body without registering in experience. And the changes that accompany a micro-arousal are measurable ones. Heart rate spikes, briefly, upward, blood pressure climbs, briefly, higher than the sleeping baseline. The stage of sleep shifts, moving from deeper toward lighter without making the full transit to waking, the way a diver might kick toward the surface and then drift back down without ever breaking into the air. You are, by every experiential measure, asleep. You have no memory of it. You will report in the morning that you slept through the noise, and you will be telling the truth, as far as the truth is accessible to you. But the body has responded. The body has registered something. The body has undergone, for a fraction of a minute, a physiological state that is closer to stress than to rest. Because the sound that arrived in the night was the kind of sound that the system decided warranted, if not a full waking, at least a brief preparation for waking, just in case. And then, when the just in case resolved into nothing, the system retreated back toward the deeper shore. One of those micro-arousals costs very little. The body absorbs it. The morning is mostly unaffected. But a night full of micro-arousals, a night in which the acoustic environment is busy enough that the system is being pulled toward the surface and retreating again dozens of times, has costs that accumulate across the hours. The sleep that results is a different quality of sleep than the sleep of a quieter night. The cardiovascular system has not rested as fully. The cortisol curve of the night, the pattern of stress hormones that rises and falls across the sleeping hours in a shape the body needs, has been disrupted in small increments that add up. The architecture of sleep, the proper sequencing of stages that the brain requires to do its overnight maintenance, has been interrupted, even though by any conscious report the night felt like a full night's rest. You can sleep through noise and still lose sleep to it. That is not a paradox. That is just the distinction between what your experience registers and what your body has actually undergone. 16. The World Health Organization in 2009 published what are called the Night Noise Guidelines. These are not comfort guidelines, they are health guidelines. The distinction matters, and the organization was careful to make it. The guidelines are not about when noise becomes annoying or when it prevents sleep in a way that the sleeper will notice and report. They are about the threshold at which exposure to nighttime noise begins to produce measurable, documented, population-level health consequences. That threshold in the guidelines is set at 40 decibels, measured as a nighttime average outside the bedroom window in units called night. 40 decibels is roughly the sound of a quiet library or a very quiet room with a clock ticking somewhere. It is not a demanding standard in terms of what it would take for most people to notice the sound at that level. It is a relatively quiet nighttime environment by the measure of most cities, most towns with regular traffic, most places where people actually live in the modern world. Below that threshold, the guidelines note, the body's nighttime restorative functions proceed largely without interference. Above it, the evidence begins to show effects, more micro-arousals, more disrupted sleep architecture, and, over time, cumulative physiological stress. Above 55 decibels, the guidelines cross from a caution into something more serious. At and above 55 decibels, the organization describes the level as increasingly hazardous to the population, a phrase it does not use lightly. At that level, the nighttime noise exposure is associated in the literature with raised blood pressure and with cardiovascular risk that extends beyond the uncomfortable night and into the body's long-term condition. Not as a single night's consequence. As a chronic exposure experienced night after night, year after year, in the rooms where people sleep in apartment buildings near arterial roads, in houses beneath flight paths, in neighborhoods where the sound of the city does not fall below 55 decibels, even at 3 in the morning. The guidelines treat noise not as an aesthetic problem, not as a quality of life problem in the softer sense. They treat it as an environmental health exposure with a dose-response relationship with population-level consequences, with the same basic logic that governs the thinking about air quality or water contamination. The sound of the night around you, in its accumulated, chronic, average form, is something the body is processing and paying for in ways that your experience of the night will not always reveal to you. 40 decibels. 55 decibels. These are not arbitrary numbers. They are the lines the evidence drew, and they were drawn by people who spent years looking at the health data of populations living at various measured distances from various sources of nighttime sound. 17, one of those sources, and it is a source that is worth pausing on, because it makes the exposure concrete and the consequences specific in a way that nighttime averages and health guidelines on their own can sometimes fail to do, is an airport. Gary Evans is a researcher who studied the effects of noise on children living near the Munich airport in Germany. The study looked at what happened to children's physiological stress response when they were exposed, chronically and without choice, to the near-constant noise of aircraft operations overhead. The outcome measured was cortisol. Cortisol is a hormone secreted by the adrenal glands in response to stress, and in ordinary circumstances it follows a specific daily pattern, highest in the morning after waking, when the body is mobilizing for the day, then declining through the afternoon and reaching its lowest point during the overnight hours, when the body is supposed to be resting. That curve is not decorative. It is functional. The overnight drop in cortisol is part of how the body restores itself during sleep, part of how the inflammatory processes of waking life are held in check. part of how the system distinguishes between the hours of activity and the hours of repair. Children who were chronically exposed to the aircraft noise above the Munich airport had measurably elevated cortisol, and elevated adrenaline, and raised blood pressure. These are not subjective reports. These are measurements taken from the children's bodies, from their blood and their urine, and they show a stress response that has been partially activated and is being held in a state of partial activation by the sustained presence of sound in the environment, sound that the body cannot ignore, sound that registers even when the child is not consciously attending to it, sound that the system treats as something to prepare for even when there is nothing specific to prepare for. The children were not describing feeling stressed. They were living, mostly, the ordinary lives of children. But their bodies were running a stress response alongside those ordinary lives, quietly, continuously, in the background of everything else. And the biological cost of running that response was not going toward anything. It was not protecting them from a predator. It was not preparing them for something they would survive. It was simply being spent in the steady accumulation of cortisol and adrenaline and elevated blood pressure, because the acoustic environment they could not escape was continuously telling the body that something might be happening. That is the thing about the ear's vigilance. It is not a system that distinguishes between sounds worth attending to and sounds that are simply loud. It is a system that responds to sound that interrupts the background, sound that deviates from the expected, and in an environment where aircraft pass overhead on a regular schedule, every aircraft is, to the body's threat detection system, another potential event worth preparing for. The habituation that comes with repetition, the conscious dismissal that the children could tell you they performed, does not fully transfer to the physiological system. The body keeps preparing. The body keeps spending the energy of preparation. The body keeps paying the cost. 18. The cortisol finding points inward. It points toward what is happening in the body, in the chemistry of the stress response. But noise has effects that point outward as well, into the world of cognition and function, and the work that people use their minds to do, and one of the clearest demonstrations of this came not from children living near an airport, but from children attending school near one. The ranch study was published in The Lancet in 2005. The lead author was Stephen Stansfeld, and the study looked at children attending schools near major European airports, including schools near Heathrow in the United Kingdom and schools near airports in the Netherlands and Spain. It measured something that might seem, on first hearing, like an odd thing to measure in the context of noise research, reading comprehension. But the choice of reading comprehension was deliberate and theoretically precise. Reading comprehension is cognitively demanding in a specific way. It requires sustained attention, the ability to hold earlier parts of a sentence or passage in mind while processing later ones. The ability to suppress irrelevant information and maintain focus on the current task. These are capacities that noise is known to interfere with, particularly in children, whose executive function and attentional control systems are still developing and are therefore more vulnerable to disruption. The hypothesis was that chronic noise exposure would impair these capacities in ways that would show up in the test scores. What the ranch study found was a linear relationship. As the measured aircraft noise at the school increased, reading comprehension scores declined, and the relationship was dose-dependent, more noise, lower scores, in a gradient that the researchers could trace across the range of exposure levels they measured. The finding held after controlling for income. The relationship was not explained by the fact that schools near airports might be in poorer neighborhoods where other disadvantages affected performance. Noise was doing something to the children's ability to read and understand and remember independently of those other factors. And the study measured not just reading comprehension, but recognition memory. The ability to recognize something you have encountered before, to reach back into the stored record of experience and find the match for what is in front of you now. This too declined with increasing noise exposure. The children in the noisiest schools were less able to hold and retrieve what they had been taught. The word that researchers use for what noise does to cognition, taken together, is a simple one. Noise taxes cognition. It levies a fee on the attentional system, a fee that is paid in the currency of capacity, and the payment leaves less available for the work of learning and remembering and understanding. The children were paying that fee daily, in every lesson. In every attempt to follow the thread of an argument or a story, in every moment of trying to hold something in mind while the aircraft passed overhead and the body quietly decided whether the sound meant anything. The effect was not about the immediate moment of the aircraft passing and disrupting the lesson. It was the cumulative effect of operating in a chronically noisy environment. The way that running an engine with insufficient oil is not a matter of any single moment of friction, but of what the sustained condition does to the machinery over time. 19. And what noise does to the body over time, accumulated across months and years of chronic exposure, goes beyond the cortisol response, beyond the disrupted sleep architecture, beyond the cognitive toll. It reaches into the heart. The World Health Organization's environmental noise reviews, built from the same body of evidence that produced the night noise guidelines, attribute a measurable burden of disease to long-term environmental noise exposure. The diseases in question are not obscure. They are among the most familiar in the clinical landscape: hypertension, which is high blood pressure. The sustained elevation of the force with which blood presses against the walls of the arteries, and ischemic heart disease, which is the condition of the heart muscle not receiving enough blood, often the condition that underlies the events people call heart attacks. The mechanism the researchers describe runs through the pathways that are by now, in this narration, becoming familiar. Repeated stress activation. The autonomic nervous system, the body's automatic control system, pushed repeatedly toward the sympathetic response, the fight or flight preparation, by the ongoing acoustic signal that something might be happening. The heart rate elevated, again and again. The blood pressure elevated, again and again. The cortisol and adrenaline present in the system at levels that were not intended to be sustained. And across years of this, across the long exposure of living and sleeping in an environment where the sound of the night and the sound of the day are above the levels the body can absorb without cost, the cardiovascular system bears the cumulative consequence of all those micro-preparations, all those small rehearsals for a danger that never fully arrives. This is the flip side of Luciano Bernardi's finding, the finding from the beginning of this long journey tonight, the one about the silent pauses in the study published in the journal Heart in 2006. Bernardi showed that 2 minutes of quiet, arrived at after stimulating sound, could produce a greater drop in heart rate and blood pressure than the relaxing music that surrounded it. The body could relax measurably and quickly when sound that demanded its attention was removed. The cardiovascular system responded to quiet the way it responds to a threat passing, with relief, with the parasympathetic shift toward rest, with the lowering of the defenses. The chronic noise findings are the slow-motion version of the same story. If silence or near silence lets the heart slow and the blood pressure drop, then chronic exposure to sound above the levels the body can comfortably hold in the background keeps the heart and the blood pressure elevated across the accumulation of days and nights, and the consequences of that elevation sustained over years are the consequences that show up in the cardiovascular disease burden that the environmental health researchers have spent decades measuring. Noise is not just an annoyance. It is, in its chronic, population-level form, a cardiovascular exposure. And the quiet that the body draws toward, the quiet that feels like relief at the end of a loud day, is not a preference or a luxury. It is the system returning toward the state it was designed to maintain when the environment gives it permission to do so. 20. And now we come to something that at first seems to be a contradiction, or at least a surprise. Because everything we have been through tonight, the ringing in the ears, the balance lost in the silent chamber, the evolutionary unease at complete quiet, the brain turning inward and vigilant in the absence of sound, all of it points in one direction, which is that silence is not a simple gift, that the body does not receive it as simply and cleanly as the wellness marketing might suggest. That total silence is something the brain actively works in, monitors, and sometimes struggles to rest inside. And then there is the 2013 study by Imke Kirste, published in the journal Brain Structure and Function, under the title is Silence Golden? And the answer the study found, unexpectedly for the subjects in the study who were exposed to 2 hours of silence per day, was something that sounds, at first hearing, like the most straightforward possible case for silence as a biological benefit. The silence group in the mouse study, because these were mice, and this is a mouse study. And that distinction is going to matter enormously before we are done with this fact. The silence group grew new neurons in the hippocampus, specifically in a region called the dentate gyrus, which sits within the hippocampus and is one of the few places in the adult brain where new neurons are known to form at all. The process is called neurogenesis, and in a brain structure that is centrally involved in memory and in the consolidation of experience into long-term storage, the production of new neurons is not a trivial thing. It is a structural change. It is the brain not just functioning differently, but building new material. The other groups in the study, mice exposed to white noise, to other mice vocalizations, to Mozart, did not show the same effect in the dentate gyrus. The silence group did. And the headline that the study generated when it reached the public was predictable and wrong, and should be examined carefully before we let it settle. Silence grew new brain cells. That was the headline. And it is technically accurate about the mouse study, in the way that technically accurate things can be deeply misleading when stripped of their context. Here is what the headline left out. The mice were mice. The hippocampus of a mouse is not the hippocampus of a human. The processes that govern neurogenesis in a mouse brain share some features with the equivalent processes in human brains, but they are not identical. And the distance between a result in a mouse model and a recommendation for a human sleeping in a bedroom is a distance that requires a great deal of evidence to bridge, evidence that for this specific finding does not yet exist. Imke Kirste's study tells us something interesting and worth knowing about how silence functions in the brain of a mouse. It does not tell us that lying quietly in a dark room will regrow your human brain, and anyone who tells you otherwise is outrunning what the science actually established. Here is the second thing the headline left out, and it is in some ways more important than the first. The silence in the study was only effective as a contrast. The mice in the silence group did not live in silence. They lived in the same mildly stimulating environment as all the other mice, and then they were exposed to 2 hours of silence as a deviation from that baseline. The silence was meaningful to the brain, the researchers argued, because it was a departure from something. It was the contrast between stimulation and quiet that produced the effect, not the quiet alone. A mouse raised in a permanently silent environment would not necessarily show the same neurogenesis, because for that mouse silence would be the baseline, not a change from it. This matters because it is exactly the opposite of the picture that the wellness framing implies. The framing implies that silence is a resource you accumulate, a substance you ingest, a pure thing that does its work the more purely and completely you receive it. The study suggests that the brain responds to quiet as a signal of contrast, as a deviation from the noisy, demanding, stimulating world, and that it is the relationship between sound and silence, not the silence in isolation, that produces whatever benefit is there to find. The silence is interesting to the brain because the noise was there first, and then the silence arrived, and the brain, in the mouse model at least, did something with that. Something in the dentate gyrus of the hippocampus that showed up as new neurons, in mice under carefully controlled conditions, in a study that has been read and cited far beyond what its scope and sample justify, and that is still, for all of that, a genuinely interesting result worth knowing about, worth sitting with in the dark, as long as it is held properly. Held in the shape it actually has, which is a mouse model, a contrast effect, a result in a specific brain region in a specific species under specific conditions, and not a proof that silence regrows the human brain or that you should restructure your nights around the pursuit of 2 hours of perfect quiet. The honest version of the Kirste finding is, in many ways, stranger and more interesting than the inflated one. The honest version says the brain does not treat silence as nothing. Even in a mouse, even measured at the level of cellular structure, the presence of silence in an otherwise stimulating life is not a neutral absence. It is a condition the brain responds to. It is, at some level, information and the brain receiving that information. In the specific region that handles memory and learning and the consolidation of experience, does something with it that looks, in mice, like growth. What that means for the human brain in the human bedroom remains genuinely, carefully, honestly unknown. The dossier does not stretch to a claim beyond the mouse. And that honesty is itself a kind of gift, because it means that the question remains open. The brain's relationship to quiet is not a settled matter. It is not fully mapped. The findings we have, taken together, are strange and contradictory and rich, and they do not resolve into a simple prescription. They resolve into something more interesting, the beginning of an accurate picture of what it is the body actually needs from the night, and what role sound plays in providing it. And that picture, the one that is becoming clearer the longer we walk through these facts in the dark, is not the picture of a body that needs silence. It is the picture of a body that needs something specific from the acoustic environment of the night. Something that is neither silence nor noise, but a particular quality of presence that we have not yet fully named, and toward which, if you have been following the thread, we are now moving. Your ears are still on. They have been on this whole time. They have been receiving the sound of this voice, steady and low and unhurried, arriving at the same pace and the same register without deviation, without the sudden change in volume or pitch or character that would tell the thalamus something had happened, something worth evaluating, something worth pulling toward the surface of experience to look at more carefully. The thalamus has been listening, and it has been, for this whole hour, or however long you have been here in the dark, deciding, not now. This is background. This asks nothing. This does not require a response. And it has been right. That is what this whole long walk through the science has been moving toward. Not a verdict on whether silence is good or bad, not a prescription for what the bedroom should sound like, but the actual mechanism, the thing that is happening right now between the sound arriving through the air and the part of the brain that decides whether to hold on or let go. And to reach that mechanism fully, there is one more distinction that needs to be made, one more corner to turn. And it is perhaps the most practical corner of all, because there is a question that millions of people carry to bed with them, quietly and usually without naming it, which is this: I sleep with a fan on, or I sleep with rain sounds, or I sleep with a podcast I have heard before, or I sleep with a voice reading something in a register low enough that it never quite demands I follow it all the way. And somewhere in the back of the mind, there is a small, uncertain thought that this habit might be a weakness, that the ideal sleeper would need nothing, that the brain, in its most healthy and rested form, would slide into silence without assistance and stay there. That needing a sound is somehow a failing to achieve the thing the body is supposed to achieve on its own. That thought is wrong, and the reason it is wrong is specific enough to name. The sounds that people reach for at bedtime, white noise, the low hiss of rain, the steady hum of a fan, the even cadence of a voice saying something familiar and unhurried, these sounds do not work the way most of us imagine they work. We tend to think of them as adding something, as providing comfort the way a blanket provides warmth, putting something between the body and the cold, as if the noise machine is depositing calm into the room, filling it with something good, layering a kind of acoustic safety over the hours of the night. That is not what they do. What they do is something entirely different, and once you understand the mechanism, the whole question of whether you need them shifts register. What white noise does, what pink noise does, what brown noise does, what the steady even hiss of a fan or the sameness of rain on a roof does, is raise what acousticians call the noise floor. The background level of sound in the room goes up. And when the background level of sound goes up, any sudden event-like sound that arrives from outside the room has a harder time standing out from it. The thalamus, remember, is not measuring the absolute volume of sounds. It is measuring change. It is measuring the difference between the background and the event, the moment when something crosses the threshold from ambient to meaningful. When the background is very quiet, the quiet of a suburban bedroom late at night with the windows closed, a door closing down the hall, a car turning in the driveway, a voice from a neighbour's apartment stands out sharply against that quiet and registers as an event. The thalamus catches it. The sleeping brain evaluates it. Heart rate stirs. Sleep stage shifts. But when the background has been raised, when there is already a continuous, even, information-free sound filling the room, that same door, that same car, that same distant voice has to clear a higher bar before it registers as something different from what is already there. The noise floor is higher. The threshold for detection has moved upward. And so the nighttime sounds that would otherwise trigger micro-arousals, that would otherwise tug at the surface of sleep without quite pulling through to waking, may not clear that bar. The thalamus receives them, but the thalamus receives them as continuous, as same, as not different from the moment before. This is masking. It does not add calm. It removes the sounds that demand a response. The distinction matters because the goal was never to fill the room with something good. The goal was always to empty the room of something disruptive. The fan is not there to be comforting. The fan is there so that the creak of the house at 2 a.m. does not separate itself from the background loudly enough to be evaluated. And when you frame it that way, the appeal of these sounds becomes completely rational. It is not a failure of the nervous system to need them. It is the nervous system doing exactly what it is built to do. Monitoring for change in the acoustic environment, flagging events, keeping the body prepared. And you, the person who added the fan or the rain machine or the steady voice, doing exactly what it makes sense to do, which is giving the monitoring system something to monitor so that it can find no events in it and stand down. In 2017, a team of researchers, including Nelly Papalambros, published a study in the journal Frontiers in Human Neuroscience that took this principle further. They worked with older adults because one of the known features of aging is that the slow wave stage of sleep, the deepest stage, the one associated with physical restoration and with the consolidation of memories from the day, becomes lighter and shorter. The electrical rhythms that characterize deep sleep are less robust in older brains. The slow waves, as they are called, happen less often and with less amplitude. What Papalambros and her colleagues did was introduce quiet pulses of pink noise being a sound whose energy is distributed across frequencies in a way that sounds to human ears like a low, soft hiss, slightly warmer and less sharp than white noise, timed precisely to coincide with the brain's own slow waves as they appeared during sleep. Not loud, not disruptive, just gentle pulses of sound, arriving in synchrony with the brain's own deepest rhythms, as if nudging along a rhythm that was already trying to happen. The results were small in sample, but clean in mechanism. The participants who received the timed pink noise pulses showed more slow wave sleep than those who did not, and the following morning their performance on a memory test was measurably better than the previous days, a concrete, testable outcome that something in the quality of their sleep had improved. The sample in this study was small. The researchers themselves were careful about what could be claimed from it. This is not a settled finding that pink noise is a proven sleep medicine. But the mechanism is real and traceable. Sound, the right kind, arriving at the right moment, can work with the sleeping brain's own electrical rhythms rather than against them. Not disrupting, not demanding evaluation. Arriving like a tide that follows the moon rather than fighting the current. That is the opposite of the sounds that cost sleep. Those sounds arrive unannounced, at arbitrary moments, carrying information. A phone notification, a car alarm, a voice rising in pitch outside the window. The thalamus catches them because they are not part of the expected background, because they represent change. Because change, in the evolutionary accounting of the sleeping brain, must be evaluated before the decision to stay under can be made. The body responds, heart rate moves, blood pressure shifts, the depth of sleep thins, and none of that has to cross the threshold of consciousness to cost you something. There was, in 2020, a careful attempt to review the full body of evidence on white noise and continuous sound as sleep aids. The review was published by Reedy and colleagues, and it surveyed the existing studies on whether steady broadband noise helps people fall asleep or stay asleep. The conclusion was honest in a way that the marketing for noise machines generally is not. Most of the studies were low quality. The results were mixed, and the evidence was not strong enough to recommend white noise as an established remedy. Some studies showed faster sleep onset in noisy environments where the broadband sound was clearly masking something intrusive. Some showed no benefit. The quality of the research, overall, did not support the confidence with which white noise is sold. That honesty is worth sitting with, because the industry around sleep sound has grown very large, and the gap between what the evidence shows and what the packaging implies is considerable. The truth is more modest and, in its own way, more interesting. The sounds work when there is something specific to mask. They work when the alternative to masking is a room that is nominally quiet, but full of event sounds the sleeping brain cannot stop evaluating. They work by removal, not by addition. And knowing that does not diminish the usefulness of the fan or the rain machine, it just relocates the explanation to the correct place. Which brings us to the name that a pair of researchers gave to the thing the brain is doing when it decides whether a sound asks something of it or not. Rachel and Stephen Kaplan were psychologists at the University of Michigan, and they spent decades developing what they called attention restoration theory. The central idea is not complicated in its broad outline, though the implications of it fan out very widely. The brain has two kinds of attentional engagement. There is directed attention, the deliberate, controlled, effortful kind that you use to focus on a task, to follow an argument, to read something difficult, to make a decision under time pressure. Directed attention is not infinite. It depletes. Over the course of a day of work and conversation and navigation and decision-making, the directed attention system tires the way a muscle tires, and when it is depleted, thinking becomes harder. Irritability rises, errors increase. And there is the other kind. The Kaplans called it the involuntary attention that is engaged by environments that are intrinsically interesting but do not demand response. A slow river, wind in trees, rain on a surface. The particular variety of ambient sound, natural, low in information, steady but not entirely uniform, that the body has spent most of its evolutionary history surrounded by. This kind of engagement is not effortful. It does not deplete the directed attention system. And critically, it allows the directed attention system to recover, not by switching it off, but by not requiring it. By giving the brain somewhere to rest its gaze, orally speaking, that asks nothing back. The research the Kaplans built around this idea was focused on natural environments and restorative attention, and most of it was not about sleep specifically. But the principle it names is the same principle that runs through every piece of evidence we have encountered on this long walk through the night. The distinction the sleeping brain draws is not between loud and quiet. It is between sound that is asking something of you and sound that is not. A city street is loud, but its loudness is only part of what makes it hard to sleep beside. The other part is that the sounds a city makes are informational. They are events. Sirens carry meaning. Voices carry meaning. A car accelerating carries a trajectory the brain can track. All of it requires, at some level of processing that never fully sleeps, the question, does this require a response? Do I need to do something about this? The answer, almost always, is no. But the question keeps getting asked. And the asking is the cost. Rain does not carry information. Wind does not carry an event. The steady hum of a fan does not represent anything that is happening in the world. These sounds fall into the class of acoustic input that the brain can receive without evaluation, without the question of response, without the thalamic gatekeeping that stands between background and meaning. They are, in the framework the Kaplans pointed at, restorative rather than demanding. They do not spend attention. They allow it to recover. And here is where the other piece of the brain's nighttime activity becomes relevant. There is a network of regions in the brain that becomes most active when you are not focused on any particular external task. When you are not reading, not making a decision, not solving something, not tracking a conversation. When the directed attention system is not at the wheel. This network is called the default mode network. It includes areas associated with self-referential thinking, with autobiographical memory, with the imagining of possible futures, with the kind of loose associative thinking that is sometimes called mind-wandering. During the day, the default mode network tends to come online in the gaps. In the few seconds between one task and the next, in the brief disengagement of a long commute, in the moments before sleep that people sometimes describe as the hardest, when the mind turns on itself and runs through everything it has not yet resolved. People find it restless. They find it uncomfortable. The sudden quiet of not having anything to attend to exposes the running commentary the brain keeps up with itself, and that commentary is not always pleasant company. This is one of the reasons that total silence, true silence, the silence of a room where there is nothing happening and no sound to receive, is for most people not the experience of peace that the wellness marketing suggests. In genuine quiet, with nothing to attend to, the directed attention system stands down and the default mode network activates. The brain turns inward, and what it finds there is not silence but itself, the day's unfinished questions, the things said and unsaid, the low ongoing freight of being a person moving through a world that asks things of you constantly. The quiet is not empty, it is full of the mind's own contents, and those contents are harder to be with than most people expect. A gentle, low-information sound changes this equation. Not by shutting the default mode network down, that would require sleep itself, or a different level of disengagement, but by giving the directed attention system just enough to track that the inward turn becomes less complete. The voice, the rain, the hum, none of them demand anything. But they occupy the surface of awareness just enough that the mind does not snap entirely inward. They provide, in the terms that acoustic experience makes available, a surface to rest against. Not so interesting that they hold you awake, not so absent that the brain fills the absence with itself. This is the mechanism that no marketing copy has quite named, because it is too specific and too strange to fit on a label. You are not using sound as a crutch. You are using sound as a signal, and the signal it sends is this: there is something here to receive. You do not have to go looking for something to do. The world is present, and it is asking nothing. You can stay here, at the edge, at the threshold between one thing and the other, and let the hours pass. The parasympathetic nervous system, the branch of the autonomic nervous system responsible for the body's rest and recovery states, for the lowering of heart rate and blood pressure and the quieting of the arousal response, responds to this signal. Luciano Bernardi's 2006 study, the one we visited early on, the one that found the pauses between pieces of music produced a greater drop in cardiovascular measures than the relaxing music itself, was measuring exactly this shift. The heart rate goes down. The blood pressure goes down. The breathing slows and deepens. These are not subjective impressions of calm. They are measurable changes in the body's state, visible in the instruments, reproducible in the data. Quiet, or the right quality of quiet, the acoustic condition in which the sounds present ask nothing of the body's response systems, produces a shift away from sympathetic arousal and toward parasympathetic rest. The calm that people chase when they turn on a rain machine or a steady voice is real. It is physiological. It is not imaginary, and it is not weakness. It is the body doing what bodies do when the environment stops asking them to be ready. There is a place in the Pacific Northwest where a man named Gordon Hempton has spent decades trying to protect something that is harder to protect than most people realize. Hempton is an acoustic ecologist, someone who studies soundscapes the way a botanist studies plant communities as living systems with their own structure and significance. And in the Hoh rainforest in Olympic National Park in Washington state, he identified a spot he called 1 square inch of silence. The name is poetic and slightly misleading. The spot is not 1 square inch. And it is not, by any measurement, silent. What it is a place largely free from the continuous background of human-made sound. The distant drone of aircraft, the low rumble of road traffic, the faint electromagnetic hum of civilization that now underlies nearly every outdoor location in the continental United States. Stand there on the right day, and what you hear is the river, and the rain, and the birds, and the occasional crash of wind through the canopy of ancient trees so large and so close together that the light inside the forest is green and perpetual, and the sound of the outside world does not reach all the way through. Hempton calls this silence. But what he is describing is not the absence of sound, it is the presence of sound that carries no human demand, no message, no information that requires a response from a human body navigating a human world. The forest is full of sound, but the sound is, in the terms we have been developing all night, fully restorative. It asks nothing. It carries nothing that the thalamus must evaluate as potentially meaningful to the safety or navigation or social standing of the person receiving it. The quietest places on earth are not silent. They are full. And this is perhaps the deepest inversion the science offers against the wellness marketing of silence as emptiness. The Hoh rainforest is considered one of the most restorative acoustic environments accessible to a human being, not because it is quiet, but because its sounds are entirely of the non-demanding kind. Every frequency present, every rustle and rush and call belongs to the category of acoustic event that the body has spent its entire evolutionary history learning to receive without alarm, without evaluation, without the energy cost of deciding whether to respond. The question of why total silence is uncomfortable for most people has an answer that is not flattering to the modern ideal of the silent bedroom, but which is entirely consistent with everything else we know. Humans have always lived in sound. For almost the entire span of human existence, which is long, longer than almost anything built by human hands, long enough that the bones of the first anatomically modern humans predate the last ice age by tens of thousands of years, the acoustic environment was never silent. There was wind. There was water. There were the sounds of animals and insects, and rain, and the creak of wood in wind, and the distant thunder of moving weather. The world was never without sound. The background was always there. What silence signals, sudden, total, complete silence, the absence not just of human noise but of all ambient noise, is not peace. It is the forest going quiet. And the forest going quiet has one primary meaning in the oldest parts of the brain's interpretive architecture. Something changed. Something made the birds stop. Something caused the insects to fall still. Pay attention. This is a hypothesis. It is offered as such by the researchers and thinkers who have explored it, and it cannot be tested cleanly because the evolutionary history of human auditory cognition cannot be run back and observed directly. But it is a plausible and well-supported hypothesis, and it fits the data. People do not relax deeply into total silence. They relax more easily into natural, low-information sound. The thalamus does not quiet most readily in the absence of sound. It quiets most readily in the presence of sound that presents no new events for evaluation. And the evolutionary logic of that, if the hypothesis holds, is not complicated. An environment producing steady, familiar, ambient sound is an environment in which nothing has changed, nothing has alarmed the birds. The forest is itself. Whatever stands between you and the night is undisturbed. That is the sound of safety, not silence, sound with nothing in it to answer. Stephen Orfield, whose laboratory in Minneapolis held for years the Guinness World Record for the quietest room on Earth, has said in interviews that the popular claim about his chamber, the widely circulated idea that no one can tolerate it for more than 45 minutes, that the silence drives people toward hallucination and panic within less than an hour, is a press exaggeration. Not entirely groundless, but not the full truth. The room is deeply strange. People do experience disorientation. The phantom sounds of the body become loud in it. And the loss of spatial information is disorienting, and most visitors find the experience interesting rather than calming. But the 45-minute figure, the dramatic collapse into unendurable quiet, has been inflated in the retelling, as these things tend to be. What is genuinely true, and what Orfield's own observations of visitors over the years support, is something milder and stranger, and ultimately more useful to understand. Most people, in deep silence, become hyper-aware of the quiet itself. It does not become a background. It becomes a foreground. The absence of sound ceases to be the absence of something and becomes the presence of something, a quality of the room that you attend to, that you monitor, that you find yourself listening into as if waiting for something to happen. The silence is louder in a perceptual sense than many sounds. It demands more attention than the hum of a refrigerator. It is not restful. It is vigilant. And this is the final piece of the picture. This is the thing that the science, counted out one fact at a time across this long night, has been building toward. The brain does not want silence. The brain was never built to want silence. The brain wants sound with nothing in it to answer, and those are not the same thing. Not even close. Silence is the absence of all acoustic input, and in that absence the brain finds not rest but the forward edge of its own monitoring systems, turned up, scanning, waiting for whatever absence of sound has historically preceded. The phantom ringing starts within minutes, because the auditory cortex, starved of input, increases its own sensitivity until it is amplifying its own thermal noise into something audible. The vestibular system becomes uncertain without the acoustic reflections it uses to model the space around the body. The default mode network activates with nothing to gentle it, and the mind turns inward to its own freight. The thalamus, deprived of the background hum that tells it everything is continuous, becomes alert to the very absence, as if the absence were itself an event. But low information sound, sound that is present, continuous, non-event, not carrying meaning, not delivering information that requires a human response, does not produce any of this. It gives the auditory cortex something to receive, so it does not fabricate. It gives the vestibular system the spatial information it expects. It occupies the surface of attention just enough to prevent the full inward collapse into default mode restlessness. It tells the thalamus, there is a background. The background is continuous. Nothing has changed. And in that telling, in that steady, even, undemanding presence, the parasympathetic nervous system is given permission to do what it is trying to do from the moment you lie down. Heart rate falls, blood pressure eases, breathing slows until it is barely a rhythm at all, until it is simply the body doing what the body must do, no longer conscious of itself doing it. This is what the research shows. Not that silence heals, not that quiet cures, not that the right number of minutes in the right conditions will regrow the brain or dissolve the accumulated cortisol of a year of difficult news. The science is more modest than that, and more specific, and the specificity is what makes it useful rather than a label on a bottle. The science shows that the acoustic environment of the night matters to the body in ways that do not require waking to register. It shows that the sleeping brain is not off. It is listening always for the thing that would justify waking. It shows that the body's stress response can be triggered repeatedly through the night by sounds that never cross the threshold of consciousness, and that this costs something. It shows that the quality of deep sleep is not fixed, that it responds to the acoustic conditions around it, that gentle sound timed with the brain's own rhythms can deepen what the aging brain has difficulty sustaining. And it shows that the body's capacity to rest, really rest, is most accessible not in the absence of all sound, but in the presence of sound that presents no new demands. Every one of those findings, taken together, adds up to the same thing. The thing you are doing right now, lying in the dark, with a voice in the room, a voice that has been speaking at the same low pitch and the same unhurried pace for however long you have been here, is not a failure. It is not a sign that something is wrong with your relationship to sleep or to quiet. It is not a dependency to be broken or a weakness to be corrected. It is the correct application of what the science, if it is honest, actually describes. You gave your sleeping brain sound with nothing in it to answer. And your sleeping brain, which has been here far longer than the concept of the bedroom, far longer than the habit of quiet as a health intervention, far longer than any advice about what the ideal sleeper is supposed to need, your sleeping brain recognized what it was being offered. It accepted it. It decided, not now. This is background. This is continuous. This asks nothing. This does not require a response. The thalamus has been standing down, in stages, for as long as you have been listening. Gordon Hempton, standing in the Hoh Rain forest with rain on the canopy, and the Hoh River somewhere nearby, and no aircraft in the sky, and no road audible in any direction, says that what he is protecting in that 1 square inch is something he thinks of as the sound of the earth undisturbed. He does not call it silence, he calls it presence. The presence of a world that is going about its own vast business, indifferent to the human schedule, older than the human voice, continuous in ways that have nothing to do with human urgency. You can stand inside it and feel, he says, that you are not being asked for anything. You can stand inside it and let the water and the wind take care of the sounds, because those sounds know what they are doing and have always known, and they do not need you to respond. That is what quiet is, when it is the right kind. Not the silence of a room that has been stripped of all input and turned into something the brain must monitor. Not the measured negative decibels of a chamber designed to test the limits of acoustical engineering, but the presence of something that has been here longer than the word for it, making sound in the dark for reasons that have nothing to do with you, asking nothing. Carrying nothing you must evaluate, steady in the way that only old things can be steady. If you have been here for a while now, if the facts have been arriving and settling like objects placed gently one at a time on a surface in a dim room, if the voice has been the only thing consistent in the space you have been occupying tonight, you have been doing the thing the brain is designed to receive. Not silence. Presence, sound that means the background is continuous. Nothing has changed. You are not needed here. Where in the world are you listening from tonight? I find myself genuinely curious. People write in from places I would never think to imagine, from coasts and from landlocked places, from cold climates and warm ones, from houses quiet by nature and apartments that have never quite stopped humming. If the mood takes you, leave a word, just a place, just a name, just whatever says where the dark is right now for you. I do read them, and there are more of these slow, long, careful walks through the science of things we live inside but rarely examine, more of them waiting, whenever you want them. But that is for another night. Tonight, the 25 facts are accounted for. The physics of negative decibels and the thermodynamics of air and the composer who heard his own nervous system in a room built to contain nothing. The cardiovascular shift that arrived not in the music but in the pauses. The mice who grew new cells in the hippocampus and the caveat that lives alongside that finding and makes it honest. The thalamus that never sleeps, the spindles that gate the noise, the micro-arousals that cost something and never announce themselves. The children near the airports with cortisol in their blood. The room in Redmond that measured quieter than hearing, and the one in Minneapolis that came before it. The brain that turns up its own gain in deep silence until it hears itself. The balance lost in the anechoic dark, the pink noise pulsing with the slow waves of older adults sleeping more deeply. The systematic review that said, the evidence is weaker than the industry. The Kaplans and the attention that restores when it is not being asked. The default mode network turning inward in the gap. The floor of silence set by the random motion of air itself, irreducible, a hard limit written by physics. And the Ho rainforest, full of sound, free of demand, where a man has spent decades standing in the rain, listening to the world as it sounds, when no one is asking anything of it. 25 facts, counted out in the dark, one at a time, each one stranger than the marketing, each one more specific and more useful than the wellness generality. Each one a small piece of the actual picture of what the body is doing in here and why it does it. The picture is not complete. It will not be complete for a long time. The sleeping brain is still among the least understood territories in all of human physiology, and the acoustics of that territory are newer science still. But the outline is there. The shape of the thing is visible. And what the outline shows is a body that has never needed silence, that has always needed exactly what the long human night has always provided, which is the sound of the world continuing in the dark, without requiring anything from you. You found your way to that tonight. One way or another, wherever you are listening from, you have been here in the presence of sound that asks nothing. And the part of you that was still watching for events, still holding the surface slightly taut against the possibility of something changing, has been, all this time, finding nothing that requires it. Let it find nothing a little longer. The facts are done. The voice is still here. The world outside is doing whatever it does in the dark without you, the same as it has always done, the same as it will do long after any particular night is over. You do not need to listen for it. You do not need to check. You're moored safe in the sleepy harbour now. Drift off